Hey there everyone, hope you are liking the series so far. In the previous parts, we built the upload flow for our image moderation app. The website can now request a pre-signed URL and upload the image in our S3 bucket. So we have already built the foundation for accepting the user input. But as you know, this is only part of our application. Now our app should focus on analyzing those images using recognition, storing the results in DynamoDB table, making a decision whether the image requires further review, and notifying the users. In order to do that, we are going to connect the processing part of our application to the upload part of our application using SQS. It is called as decoupling application components, and it is a very important architecture pattern. We will first see why decoupling is important, what advantages it provides. Then we'll look at our architecture diagram and the sequence diagram, and then we'll build the services and the code to support this decoupling. By the end of this video, our application will be closer to a real production grade AWS architecture where each component has a clear responsibility and can scale, fail, and recover independently. Okay, so why decoupling? Now, one way to build our application is to tightly connect everything together. The upload flow triggers the processing logic, and every component depends on the next component working immediately. But that is not best software architecture. In our case, let's say if recognition is slow, or if DynamoDB throttles, or the processing lambda fails, or if there are any sudden spikes in uploads, we do not want our entire application to break or become too slow and negatively impact user experience. This is where SQS comes in. Implementing decoupling using SQS will improve reliability of our application. So one component can fail without breaking the entire application. So let's say if the processing lambda fails, the upload part is still not affected by it. The users can still upload the images. It improves user experience. So the user doesn't have to wait for the entire downstream process to complete to get the response. It allows independent scaling. So in any software system, typically the processing part requires more computational resources. So in our case, if we decouple our application components, the upload part and the processing part, we can scale up processing part independently from the upload part. Using SQS also allows us to handle traffic spikes in a better way. One of the main advantages of using SQS is it can store the transactions in a queue. In our case, those are the records for the images uploaded by the user. And those messages can stay in the queue. So let's say if the processing is slow and if we have sudden traffic burst coming in with multiple users uploading images, they are not going to get lost. They are just going to stay in the queue. And eventually the processing part will catch up and process those images. It also adds retry capability. So if for some reason, if any processing job fails, it can be retried automatically. And to add on to that, it also supports dead letter queues for the messages that fail repeatedly. So let's say for some reason, one of the images that the user has uploaded is failing multiple times. We can put that message in the dead letter queue and then have a support team to take a look at it. So it allows for better investigation, not only of the user submitted content, but it may also result in changes to the application logic if required. Okay, so now that we are clear on why decoupling is important, let's go back and look at our architecture diagram. Okay, so here is our architecture. So in our previous parts, we already built this website and we enabled this website to get a pre-signed URL from this Lambda function and upload the images in the S3 bucket directly from the browser. We are also creating our initial upload record in the DynamoDB table. So now what we are going to focus in this video is whenever an object is created in this upload images S3 bucket, we are going to trigger a Lambda function, and that Lambda function is going to put a message for our processing part of our application in the SQS queue. So in order to do that, it is going to read the information of the object from the S3 bucket, and it is also going to read the information for the upload record that we created when the pre-signed URL was returned to the browser. So here is our sequence diagram. So if you have noticed, I added some of the swim lanes now from our last part. That will focus on what we are going to build in this part. So we have done up till here in the last part where the object is created when the browser uploads the image directly in our S3 bucket. So next thing that we are going to do in this video is to capture that event, the S3 object created event, which will trigger our S3 to SQS Lambda function. That Lambda function will first query our database to get the record back, the upload record back, and then using the information from the S3 object created event and the upload record that we have stored in the DynamoDB table, it will create a message and it will put that message in the SQS queue. And then it will also update the DynamoDB table to reflect the new status. The message that we are going to put in this SQS queue is going to be very simple. It essentially will have only 5 data fields: username, user email. Those will come from DynamoDB table. S3 object key, S3 file name will come from our S3 object created event. And the upload ID, we can either get it from the table, DynamoDB table, or if you remember, all of our objects that we create in S3 will have the upload ID as part of the file name. So we can get it from there. And once the message is created in this SQS queue, in the next part, we will see how to poll for the message and start processing the images. But for this video, this will be our endpoint where the message is created in the SQS queue and we can see that message in there. Okay, so let's get started. Okay, so as you can see, I have logged into my AWS account and let's first create our SQS queue. So go to simple queue service. So I have recently visited it, or you can just type it in the search box. You can type SQS and go to the SQS from there. And first thing that we are going to do is click on create queue. So this will be a standard queue. The name of the queue is going to be image moderation queue. And I'm going to keep all the other parameters as default. Just as a note, I'm not going to enable dead letter queues, but in production systems, in the real world applications, it is a good idea to enable those. Okay, so let's create queue. All right, the queue is now created. So once a queue is created, along with the ARN, we also get a URL, and we will see how it comes in picture in just a while. Okay, so our queue is created now. So let's create the Lambda function, which will put the information in this queue. Okay, so I'm going to open up a new tab and I'm going to go to Lambda. And right now we only have one Lambda function, this get upload URL, which returns the pre-signed URL. So now we are going to build another one. So let's say create function. For the function name, I'm going to say S3 to SQS. And I'm going to select Python 3.14. So depending on when you see this video, you may have a different Python version here. It's just that this is the latest version when I made this video. And then let's create this function. Okay, so the function is now created. And let's enable our S3 object created event to trigger this Lambda function. So in order to do that, let's go to our S3 bucket. So I'm going to open up a new tab and I'm going to go to S3. And as you know, we have two buckets. This bucket contains the website files, the JavaScript, CSS, HTML. And this is the bucket where we are actually uploading the images. So click on that bucket. And as you know, we have the uploads prefix. So all images that are uploaded will be uploaded using uploads prefix. And we already have a couple of images in there. So let's go back to our bucket and let's go to properties and let's enable the event trigger for our Lambda function. So scroll down all the way until you see event notifications, and then create event notification. So event name, I'm going to say image uploaded, and the prefix is optional, but we know that all of our images are going to get uploaded with the uploads prefix, so I'm going to specify that. And for the event types, as we said, I'm going to say object created put. So any new object created in this S3 bucket using uploads prefix, this event will be triggered. And for the destination, so Lambda function is selected by default, and we can choose our Lambda function in here. So now you should see our new function, which is S3 to SQS, and save changes. Okay, so the event notification is created successfully. So if you go back to our Lambda function and refresh this page, you will now see a trigger to this Lambda function. So S3 object created event will trigger this Lambda function. So we built that connection already. Okay, so let's see what that event actually looks like. So what I'm going to do is I'm just going to print the event that is coming in our CloudWatch logs and see what information it contains. So let's deploy this Lambda function. And for sake of testing, I'm just going to upload a sample image in our S3 bucket. It wouldn't have the UUID, but that's okay. I just want to see whether this connection is working and what information is passed in the events parameter. Okay, so go back to our S3 and uploaded images, and under uploads prefix, I am going to upload a sample image file. Add files. And for now, I'm just going to select this simple AWS tutorials logo. And let's say upload. Okay, so the image has been uploaded, or the object has been added in our S3 bucket with uploads prefix. Now our expectation is this action that we just did should have triggered this S3 to SQS Lambda function, and that Lambda function should have written what the event information is in our CloudWatch logs. So let's see if it did that. So go back to our Lambda function and select monitor and click on CloudWatch logs. Okay, so this is the latest CloudWatch log, and let's see what information that we have printed here. So if you expand this, we have printed the event parameter, right? So what I'm going to do is I'm going to copy this, and before I do that, before I paste it, let's quickly see what information it contains. So the information that we are most interested in is the object information. So see, it has the key for our file that we uploaded, and it also has the bucket name and all the other information. So the idea is, right, when in our system, when the user uploads any image file, we will get this key, which will be uploads UUID underscore file name. So we can get UUID from there, make a call to our DynamoDB table, read the information for that upload, and then create that message for our SQS queue. Okay, so I'm just going to copy it for our reference, and I'm going to paste it in our Lambda function so that as I build the code, I will have an easy reference to what event parameter contains. Okay, so I pasted this event and commented it out. I no longer need this line, so I'm going to remove it. And let's start building the code. And before we do that, let's add some environment variables. So go to configuration and click on environment variables, and let's add a few. So first one I'm going to add is the name of our DynamoDB table. So I'm going to say DDB table. And what is the name of our DynamoDB table? Let's quickly take a look. Go to our DynamoDB, and under tables, this is the table that contains the records for our uploads. So I'm going to add that in. I'm going to add another one, which is SQS URL. So remember when we created the SQS queue, we got this URL. So I'm going to copy this and I'm going to add it here. And finally, uploads prefix. So this is the prefix with which the objects will be created in our S3 bucket when the user uploads the image files. And that is simply uploads. Okay, so I'm going to save those. And if we need more, I can always come back and create more environment variables. But for now, I think we are good. So let's go back to our code and let's start by importing the required libraries. So here we are going to need Boto3. So let's start writing the code now. So let's first create our client. So we say SQS is Boto3 client SQS and DynamoDB is Boto3.resource DynamoDB. Okay. And now under this event, let's first read our environment variables. So ddb underscore table is OS. DDB table. Okay. And SQS URL is SQS URL. And upload prefix is upload prefix. So it's a good idea to add comments in there. So I'm just going to say read env variables. Okay, so now that our environment variables are there, let's read the information from this S3 object name or object key rather. Okay, so the way we do that, so let's say for record in event dot get records, so if you notice, the event parameter has a records list. So we are going to read from there. And I'm going to say S3 info is record.get S3. So essentially it will have this information. And from there, let's read the bucket. So bucket will be s3.info. Amazon Q has actually auto-completed it. So let's take a look whether that's the correct way. Info.get bucket and name. So under S3, bucket and name. Okay. Now let's read the object key. So object key will be object underscore key equals, and let's see if Amazon Q has put it correctly, which I think it did. S3 info, which is this variable, or this, it will have this value. Under object, read key. Okay, so all good there. And let's quickly do a validation. So let's say if not bucket or not object key starts with upload prefix, I'm just going to print invalid object name or bucket key, and I'm going to continue. Usually in our Lambda functions, we return something back, but in this case, this Lambda is triggered by our S3, right? So the S3 put object event is going to trigger this Lambda function. It is not going to handle if we return anything back to it. So I'm just going to say continue. So that's the distinction here from typical Lambda functions that we otherwise write. So now let's extract the upload ID from our object key. So if I go back to our uploaded images, so this is going to be a standard format for our uploaded image files. So it will have a UUID followed by an underscore and then the actual file name that the user has selected. So I'm just going to copy this because that is what we will see in a real life application that we have built. And I'm going to, instead of this sat log, I'm going to do this so that I have a reference of what the actual event would look like. So let's read the upload ID from this information. So let's first get the actual file name. So file name is going to be our object key, and Amazon Q has given us some instructions, but in this case those are not true or not correct. So what we are going to do is, we know our object key will always start with uploads prefix. So we can say length of upload prefix, and we will read everything to the right of it. So as you know, our uploads prefix is uploads with a /. So it will read everything to the right of this string. So it will essentially read the entire object file name. And from there, let's extract the UUID. So UUID is going to be, upload ID is going to be, so now we have the file name, right? So we are going to split this file name by an underscore, because we know that our format is always going to be UUID underscore file name, right? And then we will get, it will essentially split this file name into two elements, which first will be the UUID, upload ID, and the second is the actual file name that the user has selected. So we will read the first part of it, which will be the upload ID. Okay. So now let's fetch the information of the upload record from DynamoDB table. So I'm going to put a comment, fetch information about the image upload from DynamoDB. Okay, and let's create our table object. So table is going to be our resource, Dynamo resource, which is dynamo.table.ddb table, which is our environment variable where we specified the name of our table. And now let's get the information from this table for the upload ID. So we can say database response, database underscore response, or RESP, equals table.get item, and key is going to be upload ID, which will be upload ID. So let's quickly confirm whether this is indeed the partition key. I think it is, but it's a good idea to confirm that. So if you go back to our DynamoDB table, so we have specified the partition key as upload underscore ID, and that is what we have specified here. So all good there. So now this database RESP variable should get the information for the upload record. So for now, I'm just going to print this out and see what we are getting back. Print database response. I'm just going to say DynamoDB information. It's database response. Okay. So before we do anything further, let's test this part of our code out to see if it is working fine. So I'm going to deploy this Lambda function. So the next thing that I'm going to do is, remember in our previous videos also, I gave an idea about how to approach permissions. So every time we had to ask two questions: what this resource is supposed to do, and does it have necessary permissions to do that? So in this case, our resource, which is S3 to SQS Lambda function, is supposed to read the information from a DynamoDB table. Does it have the permissions to do that? It doesn't. So let's add those permissions before we test it out. So let's go to configuration, go to permissions. And if you see here, this execution role for our Lambda function has only permission to put information in the CloudWatch logs. it doesn't have information to read from our DynamoDB. So let's add that. So open this execution role. It will open up in a new tab. And let's say add permission, create inline policy. And for the service, because we are reading from DynamoDB, select DynamoDB, right? And the actions. So we are going to read the information from DynamoDB. So I'm going to say read and get item. So essentially, if you go back to our code, this is what we are doing, table.get item. Okay. And for the resource, we have to provide this resource. We can provide it for all of our DynamoDB tables, but that's a bad security practice because we should have the least possible privileges to any of our AWS resources. So by default, AWS asks us to specify a individual resource. So I'm going to do that. So click on add ARNs and let's go back to our DynamoDB table. And let's get the ARN from there. Copy the ARN, come back to our policy, and in the resource ARN, let's paste that in, add ARN. So now this Lambda function will have get item privilege on this DynamoDB table. Click on next, and let's give a name. So we can say S3 to SQS. I'm just going to capitalize this, and I'm going to say DynamoDB table name, which is image upload requests. I think there is a space here, so yeah. And what type of resource it is DynamoDB. And what type of permission we are providing. So we are going to provide get item permission. So this is a way that at least I use to specify the policy names. So it identifies our resource. It identifies on what resource the permission will be granted. What is the type of the resource on which the permission is granted. And finally, what permission or permissions that we are granting. So create policy. Okay, so now the execution role has the read information for our policy. Now let's test it out. So one way to test this Lambda function is actually go back to our front end, upload the image and see if the Lambda function is executing and get the information from there. But there is another way of testing it out, which we are going to do from here. That's another important way that you should know. So under our Lambda function, there is a test tab next to code. So go there. And let's say create new event. So let's say test event SQS S3 to SQS. We don't need multiple, so it's okay. We don't need multiple events. And here we have to provide the JSON for our test. So this is the object that will be passed to our Lambda function. So essentially we are mimicking what S3 object created event will send over to our Lambda function. So if you remember, we printed that in our CloudWatch logs. So if you go back to our CloudWatch, this is what we received when we uploaded that sample image file in our S3 bucket. So let's copy that. And I'm going to copy that in a text editor of my choice, which is Sublime Text. So this is not a valid JSON. So let's first convert that into valid JSON. And we don't need event here because that is passed to our event parameter in the Lambda function. So in order to make it into a valid JSON, let's do find and replace. And we'll take all of our single quotes and replace them with double quotes. Okay, and let's see if now it is a valid JSON. So copy it down and go back to our Lambda function, and under event JSON, let's put this and say format JSON. So if it's a valid JSON, it will format it. If not, it will give an error. So in this case, it did not give an error and formatted the JSON. So this is good. And I'm going to save this test event now. The other thing that we have to change here is the file name, because remember we uploaded a test file which is not in the format of the actual files that will come in. It doesn't have the UUID. So let's get the valid file name, right? So this is a valid file name. So that is the only thing that I'm going to change in here now, is the key is going to be this. Okay. And I have already checked that for this UUID, we have a record in the DynamoDB table. So this is our UUID. And if you go back to DynamoDB, and if we say explore table items, you will see one table item in here, which is this UUID with the username of mkelly@gmail and username as Mark Kelly. Okay, so now I think we have done everything that we can to test our Lambda function. I'm just going to close this and I'm going to click on test. So our expectation is once we click on test, this code will execute. This code will read the information from the S3 bucket for that file that we specified, this file, right? It will go to DynamoDB table and read the information from there, and it will print whatever response that it gets in our CloudWatch logs. So let's say if it is achieving all what we expect it to do. So click on test and the execution has failed. Oh, so it says name OS is not defined. I did not import the library, looks like. So yeah. Okay, so let's import the library. All right, and we'll have to deploy the function again. Okay, so hopefully that should be good. Now let's go back to our test tab and click on test again. And this time it says starts with first arg should be a str. Okay, so let's say where the starts with problem is there. Let's see what our environment variable is. Oh, it is uploads prefix, and that is the reason why it failed. So essentially it read the upload prefix, there is no such environment variable, so it was none type, and then this resulted into an error. So let's actually, it is, I would say it is upload prefix, not uploads prefix. So instead of changing the code, I'm changing the name of the environment variable that we specified. Okay, so now let's test it again. So go back to our test tab. Okay, so let's test it again. So go to our test tab and let's just test it with our event that we created. Oh, so this should be split. Okay, deploy. Okay, so let's test it again. And we got our success message back, and let's see what information it has returned or printed. So we have printed this DynamoDB information. So we did get our username and the user email address, right? So this is username, and let's see where our user email address is. Okay, it's here. So yes, so we have proved that if our Lambda function is triggered from S3 object created event, it can get the UUID from the S3 object and object key rather, and get the information from the DynamoDB table. Okay, so let's continue modifying our code. So now it has to put this information in the SQS queue. So in order to do that, I'm going to comment this out, and I'm going to say put information in SQS queue. Okay, so let's first build the message that we are going to put. So remember, going back to our sequence diagram, we are going to send these 5 data variables in there: username, user email, object key, file name, and upload ID. So let's do that. And if you see from our DynamoDB response, we are getting the information of that record in the item list. So let's read the information from there before we do anything further. Let's read the item first. So let's say item equals database response dot get dot item. So it will essentially get this list. So let's first check if we have the item object in the response. So let's say if not item, print no matching upload ID in the database. Okay. Build the message that we'll put in the SQS queue. Now remember, going back to our sequence diagram, we are creating the message with these 5 data fields. So let's create the message. Go back to our code. I'm going to put it in the full screen mode. Okay, so let's say message equals, and I'm going to create the message. So what are the elements here? Username, user email. So let's do that. So username. Now how we are going to get the username? We are going to get it from this items list. So we can say item.get, and it is not username, it is user underscore name, it is user name without any underscore in it. User email, again item.get, user email. So Amazon Q is very helpful in some cases, but sometimes it just puts some wrong information in. It's our job to verify the output of Amazon Q. Okay, so next we are going to put is S3 object key, right? So you can say S3 object key. Actually, I'm going to capitalize S, which is going to be the object key that we have already read from the S3 information that we got. And the S3 file name. So I'm going to say S3 file name is file name which we have read from the information that we got in the events parameter after the object is created in S3 bucket. Now let's put that message in the SQS queue. So we can say SQS underscore send message, and it is actually message body. So what is the queue URL? That's our environment variable. So now that we have created a message in SQS queue, I want to update the status in our DynamoDB table. So if you remember, when we wrote the code to return the pre-signed URL back to user, the upload record has a status of upload underscore URL underscore created. So now I am going to change the status something to reflect that the image is present in the S3 bucket. Okay, so let's go back to our code and let's update our table. So table dot update item, update underscore item. And okay, so it has given us some information, Amazon Q. So upload ID is upload ID, right? Now update expression is set, and because status is a reserved keyword, we have to do this underscore s equals I'm just going to say new status. And now we have to provide what those expression attribute names are. So that is expression attribute name is status. So So if you go back to our table, this is the attribute name and what value it's going to contain. So this new status, right, will have a value of image uploaded. Okay. And finally, let's return, although it doesn't make any difference, we can say image uploaded and ready to process. Okay. So deploy the Lambda code. And now a couple of things that we had to do. We just added code in our Lambda functions to put the information in SQS queue and to update our DynamoDB table. Now we need to add permissions for this Lambda function to do so. So go back to our configuration tab. Under permissions, right now we have permission to read from the DynamoDB table, but now we have to specifically provide permission to update an item in the DynamoDB table. And we also need to provide permission for our Lambda function to put a message in the SQS queue. Okay, so let's do that. So let's click on our execution rule. It will open up in a new tab. And we have created this policy. So let's first create the DynamoDB update item policy. Click on add permissions, create inline policy, select service, DynamoDB, and we are updating an item now. So it has to be a write policy or write access level. And under that, it is, we are updating an item. So update item. And for our resource, it's our table. So we add the ARN for that table. Go back to our table and copy the ARN and paste it here. Okay, and then let's provide a meaningful name. So as we do, it is going to be S3 to SQS. What resource? So it is going to be image upload requests. What type of resource? DynamoDB. And what permission? Update item. Create policy. Okay, so now our Lambda function has permission to read from this and also update the item. Now we can actually put it in one permission, so we can have multiple actions associated with each inline policy. For the sake of simplicity, I created two, but essentially you can actually merge them into one permission policy as well. Okay, so now let's do the permission for SQS queue. So again, create inline policy. Now here service is going to be SQS, and we are writing a message in SQS queue. So under write, say send message. And what is the resource? So again, we are going to add the ARN for our SQS queue. So click on add ARN and let's go back to our queue. And here is our ARN. So copy that and paste it here. Add ARN. Say next. And as we do, it's S3 to SQS. And what is the name of the queue? Image moderation queue. And what is the type of this service or resource? Is SQS. And what is the permission? Permission is send message. Create policy. Okay. So now our function has the required permissions to update the DynamoDB table, read from DynamoDB table, and put the message in the SQS queue. So let's go back to our test And let's try to execute this test again. So our expectation is it will read the information from our DynamoDB table. We have already seen that working. And then it will put a message in our SQS queue. So if you go back to SQS queue, right, and if you say send and receive messages, and let's say poll for messages, right now there are no messages in our SQS queue. Our expectation is once this Lambda finishes processing, we will see a message with those 5 data attributes that we have seen earlier in this SQS queue. Okay, so let's go back to our Lambda function and let's test it out. And looks like everything is fine. So let's go back to our SQS queue to see if we have seen this message. And here you go. So this is the message that our Lambda function just created, and it has the information or those 5 data fields that we have seen earlier. So what we have achieved in this video is we have successfully created a message in our SQS queue about the uploaded image. In the next part of this series, we will build the functionality where we will read these messages, use Amazon Rekognition to analyze the image to see if they contain any restricted categories, and notify the users or the admins depending on whether they contain any restricted categories or not. So I hope you like this video. If you are liking this content, I would highly appreciate if you can give a like and consider subscribing to the channel, and I will see you in the next part.